Right, to understand Pascal triangle, let's do some expansion. Alright, so if we're going to expand bracket 1 plus b to the power of 0, anything to the power of 0 is 1, so you get 1 there. And if you're going to expand 1 plus b to the power of 1, you'll just get 1 plus b. Alright, so if you want to expand bracket 1 plus b to the power of 2, you can use your algebraic identity. Bracket a plus b to the power of 2, that gives you a squared, which is 1 squared plus 2 times 1 times b plus b squared, and that gives you 1 plus 2b plus b squared. Okay, so for the expansion of 1 plus b to the power of 3, right, you can take whatever you have done earlier on, which is 1 plus b to the power of 2, multiply with another 1 plus b. Then you can use your distributive law, right, to get the answer there, 1 plus 3b plus 3b squared plus b to the power of 3. Likewise, you can use distributive law to get 1 plus b to the power of 4. Okay, so if you were to look at, there's a certain pattern there, alright, so if you have 1 plus b to the power of 0, right, you get 1 term. If you have 1 plus b to the power of 1, you have 2 terms there. If you have 1 plus b to the power of 2, you will have 3 terms. And if you have 1 plus b to the power of 3, you end up getting 4 terms. And if you have 1 plus b to the power of 4, you end up getting 5 terms. 5 terms here. 1, 2, 3, 4, 5. Right, so these are the expansions we've done earlier. What we're going to do is I'm going to put all this expansion in the table format, and then from the table format, we will try to form the Pascal triangle. All right, there are 2 things we need to explain here. The first one is, what does it mean by this word binomial? Right, so binomial means it's a 2 terms expansion. The word bi means 2. So binomial means we're talking about 2 term expansion. So where are the 2 terms? If you're going to use this as an example, 1 is your first term, your b is your second term. So this is a 2 term expansion. So this is called binomial. If you have a 1 plus a plus b, all right, this is considered 3 terms expansion, and this will be called trinomial. All right, so what does this word coefficient means? Coefficient means it's the number in front of your variable. All right, so if you look at the first example, okay, when n is equal to 0, anything to the power of 0 is 1. Right, so where is the variable? So 1, actually, you can write it as 1 times b to the power of 0. Right, so the coefficient in front of b to the power of 0 will be 1. That's why we have a 1 there on the first row, third column, second row, third column. Now when n is equals to 1, the expansion you get is 1 plus b, and 1 plus b can be rewritten as 1 plus 1b, right? Okay, 1, you can write 1 as 1 times b to the power of 0, and then b, you can write it as 1 times b. So can you see that the coefficient here will be 1 in front of the b to the power of 0, and in front of the b, it's 1. So therefore, the binomial coefficient will be 1, 1. Okay. Likewise, for when n is equals to 2, right, you can write it as 1 times b to the power of 0 plus 2b plus 1 times b to the power of 2. So where are the coefficients? It will be 1 followed by 2 followed by another 1. Okay, so likewise when n is equals to 3, right, the coefficients will be 1, 3, 3, 1. And when n is equals to 4, it will be 1, 4, 6, 4, 1. Right. So if you look at the columns, if you look at the third 1, 2, 3, third columns, you look at it very carefully, right? There is a certain patterns that we can observe. All right, what is the patterns that we can observe? Right. You can see that at both ends, right? Can you see at both ends, you have all the ones. All right, that is the first pattern. And then it's symmetrical. If I'm going to draw a line that cuts through, you see it's symmetrical along that line. Okay, then the third observation, which is very important, right? If you look at this, when n is equals to 2, look at this row. Okay, right. Look very carefully. How do I get this number 2? Right, to get this number 2, you look at the row above it, which is n equals to 1. Can you see that actually take a 1 plus 1 and you will get 2. Okay, let's look at another example. Another example is, let's look at the third row. Okay, let's look at this number here. How do I get this number 3? To get this number 3, we have to look at the row above it, which is n equals to 2 here. All right, and how do I get 3? Can you see? Look at the two numbers that's above 3. The two numbers that's above 3, that will be 1 and 2. And if you take 1 plus 2, you get 3. So likewise, for this number here, 3, look at the two numbers that's above it, which is your 2 and 1. So 2 plus 1 gives you 3. Okay, now let's look at n equals to 4. Let's look at this number here. Right, how do I get 6? To get 6, you have to look at the row above it. Look at the two numbers that's above it, which is 3 and 3. So 3 plus 3 will give you 6. All right, so if I want to find the binomial coefficient when n is equals to 5, right? Right, so what are they? As what we have said earlier, at both ends, you'll start off with number 1. Right, so the next number, you get it from the row above it, which is 1 plus 4. Right, that gives you 5. And then the next number will be 4 plus 6. That gives you 10. Right, and the next one will be 6 plus 4. 6 plus 4 gives you 10. 4 plus 1 gives you 5. All right, so how do I form the expansion with this binomial coefficient? Now we know that what should be in front of your variable. Then how do you form the expansion? So the expansion goes this way. It will be started with 1 because it's 1 times b to the power of 0. So it's not necessary to write b to the power of 0 because b to the power of 0 is 1. So it started with 1 plus 5b plus 10b squared. So can you see it starts from b to the power of 0 to b to the power of 1, b to the power of 2, followed by b to the power of 3, followed by b to the power of 4, and the last term is b to the power of 5. So when n is equals to 5, you get the last term is b to the power of 5. Right, and you see that you start with b to the power of 0. So 0, 1, 2, 3, 4, 5. They're all together 6 terms. Right, so you should get one term more than the number you get for your n. So when your n is 6, all right, are the binomial coefficient? You will start off with 1 again. 5 plus 1, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. End off with the 1. Right, so how do I form the expansion? So it will be 1 plus 6b plus 15b squared plus 20b cubed plus 15b to the power of 4 plus 6b to the power of 5, and the last term is b to the power of 6. That's how you do it. Right, and if you were to observe very carefully at the third columns, even at the second columns, can you see that you can actually draw a triangle? Right, so that's why this is how the Pascal triangle comes about. Right, there's some limitations of the Pascal triangle. What is the limitation? For example, if you want to find the binomial coefficients for n equals to 100, then you will need to know the binomial coefficients for n equals to 99. And to know the binomial coefficients for n equals to 99, you will need to know the binomial coefficients for n equals to 98, and so on and so forth. So hence, it's not practical to continue, and it is also not efficient way to expand a binomial if it's raised to a very large power. However, not all is lost, because the binomial coefficients in the Pascal triangle can be expressed in this form, right? And this is called the combinations formula. This is actually the formula that will be used in probability, but we will not be dealing with that chapter. We'll just be learning how to use this combinations formula, how to apply it in and use it in the binomial theorem. All right, let's do a recap on what we have learned earlier on Pascal triangle. So when n is equal to 0, that means you are actually expanding bracket 1 plus b to the power of 0, you get 1. So the binomial coefficient is 1. When n is equal to 1, that means you're expanding bracket 1 plus b to the power of 1, you get 1 plus 1b. So the binomial coefficients will be 1, 1. Then when n is equal to 2, you get 1, 2, 1. N equals to 3, you get 1, 3, 3, 1. N equals to 4, you get 1, 4, 6, 4, 1. N equals to 5, you get 1, 5, 10, 10, 5, 1. All right, so how are these binomial coefficients, how is it related to the combinations formula that we spoke of earlier on? Right, so your first term 1 is equivalent to the combinations formula of 0, 0. Right, and when n is equals to 1, right, this 1 here is equivalent to 1, 0. And the second one is equivalent to 1, 1. And when is equals n equals to 2, it will be equals to 2, 0. And then 2, 1, 2, 2. When n is 3, you start with 3, 0, 3, 3, 1, 3, 2, 3, 3, so on and so forth. All right, so we can actually, what happens if when n is equals to 5, or n equals to 6, sorry. When n equals to 6, you will get 1, 6, 15, 20, 15, 6, 1, right? So what would be the combinations formula be? It will be 6, 0, then followed by 6, 1, followed by 6, 2, followed by 6, 3, followed by 6, 4, 6, 5, and then 6, 6. Right, so how would the binomial theorem looks like then? Alright, so if n is equals to 5, recall the expansion, it's 1 plus 5b plus 10b squared plus 10b cubed plus 5b to the power 4 plus b to the power 5. So 1, we explained earlier on that we can actually write 1 as 1 times b to the power 0. Okay, and from the earlier slides, okay, the two triangles, if you were to recall, the two triangles, right, when n is equals to 0, right, the binomial coefficient is 1, right, and 1, it's using the combination formula, you can actually write it as 0, 0, right, and then when n is equals to 5, right, you would have 1, 5, 10, so on and so forth. So the combinations formula for 1, you can write it as 5, 0, then followed by 5, 1, and so on and so forth, right? So this is what we're going to do. We're going to substitute the binomial coefficient. We're going to substitute the binomial coefficients with the combinations formula. Right, so this number 1 here will be substituted with the combinations formula 5, 0. This one here, this binomial coefficient, right, will be substituted with 5, 1, and then 10 will be substituted with 5, 2, so on and so forth. Right, so if you're going to do it for a general form, so it will look like this. If you want to expand 1 plus b to the power n, when n can be any positive integer, then how would the expansion be like? So it would be bracket n0 b to the power of 0 plus n1b. You know, it starts with b to the power of 0, then 0, then b to the power 1, b to the power of 2, so on and so forth. So this will be your general term. Okay, so this will be how a special form of the binomial theorem looks like. And we're going to do some examples on it. Right, so before we can do some examples using the special form of the binomial theorem, we need to know how to use the calculator to evaluate the combinations formula. Alright, so let's look at all these steps here. Depending on what the brand of a calculator if you're using the same as mine, even if you're not using the same as mine, I think on your calculator, right, you should be able to see this NCR pad on your calculator. Right, so step 1, alright, depending on what you want to evaluate, let's say for example you want to evaluate 2, 0, so 2, 0 is just 2C0. So what's the first step you need to do is you have to press the number 2 keypad, right, then followed by the shift keypad, and then followed by NCR, then followed by 0, and you should get 1. So let's say if we want to evaluate 5, 2, right, so 5, 2 is 5C2, right, so what are the steps involved? So you press the 5, press 5 first on the calculator, followed by the shift key, followed by the symbol NCR. You should see on the calculator 5C, and then followed by the number 2, and you get 10. So this is not difficult. Right, let's try. Supposing I want to find 5, 2. But remember the steps. So what's the first step? So 5, 2, it's the same as 5C2, right? So the first step is to press the 5 on the calculator, press the number 5 on the calculator, followed by the shift key, followed by the symbol NCR, followed by the number 2, and you should get 10. Okay, let's practice some more. Let's say if you have 7, 3, how do you evaluate? So that will be 7C3. Okay, press the number 7, followed by the shift key, followed by NCR, followed by 3, and you should get 35. Right, so what happens if I want to find 4, 4? Okay, 4, shift, NCR, 4, you get 1. What happens if I want to get 5, 5? 5, shift, NCR, 5, you get 1. If you want 6, 6, you should also get 1. So from here, we can have a general form that is, if you have n, where n is a positive integer, you would get 1. And then another observation is, let's say if you want to find 4, 0, so 4, shift, NCR, 0, you get 1. Likewise, 5, 0, you will also get 1. If you have 6, 0, you get 1. So from here, again, we can have a general form that if you have n0, where n is a positive integer, you will get 1. You are ready to do an example, right, using the theorem. Let's write down the theorem first. Alright, we're going to simplify it because earlier on we understand that n0 will gives you 1 and b to the power of 0 will be 1. So the first term is just 1, and second term is n1, b to the power 1, n2, b2, general term is nr, br, and then the last term will be, because n it's gives you 1 also, so the last term will be b to the power n. Alright, so if you're going to compare this with the theorem, right, of course 1 is comparable with the 1, so the letter b, you can substitute it with 3x, then you can substitute your n with the number 9. Alright, so if n is 9, then you're going to expect to have 10 terms. Okay, we're not going to expand all the 10 terms. Okay, we're just going to expand up to the first 5 terms. Okay, so we should just expand up to what did I say? I think 4th term lah. Okay, expand up to the 4th term. All right. Okay, so let's begin. Right, so the first term is 1 plus n is 9, 1. Your b is substituted with 3x, so bracket 3x, followed by 9, 2, bracket 3x, open bracket 3x, open 3x, close bracket to the power of 2. All right, here I need to sidetrack a bit, the importance of putting a bracket, because you are actually squaring the whole 3x. All right, So what you get here, it's actually bracket 3 to the power of 2 and then x to the power of 2. You should get 9x squared here. If you don't put a bracket and if you write it this way, can you see that you are just squaring x only? So 3x squared is just 3x squared. Okay, 3x squared will not give you 9x squared. Hence, it's very important that you put the bracket there. Okay, so we're going to do up to the fourth term. So I have 1, 2, 3. So I need another one more. So plus 9, 3, bracket 3x, close bracket to the power of 3. So there are another 6 more terms behind. Okay, we're not bothered because we only want to expand up to the fourth term. So let's simplify. So you get 1. Use the calculator to evaluate 9, 1. You should get 9. Just press 9. Shift NCR 1. You should get 9. So that will give you 9. Then bracket 3x. 9, 2 will be 9. Shift NCR 2. That gives you 36. Okay, here we're going to apply this rule that you have learned in your indices. If you have bracket a, b to the power m, a means a to the power 1, b means b to the power 1, and then you get a to the power 1 times m is m, and you get a to the power m and b to the power m, right? So we're going to apply that. So you have bracket, close bracket, 10 to the power of 2, open x to the power of 2. Okay, 9, shift n0 3, 84. Bracket 3 to the power of 3, x to the power of 3. Alright, let's simplify further. So 9 times 3 is 27. 36 times 9. 324. 84 times 27. 2268. Okay, right. So when you do binomial expansion, you just need to be very careful. Important things are if there should be a bracket, you just make sure you do the bracket correctly. Apply the indices, the rules that you have learned in indices. Like for example, this one here, apply it correctly, and so most of the time you should be able to get an answer. Practice what we have learned. Let's write down the formula first, the theorem first, sorry. So if you have 1 plus b to the power of n, right, that will gives you n0, right, b to the power of 0 plus, okay, I think we can simplify that because we already learned earlier that n0 is 1, b to the power of 0 is also 1. So we can simplify this to be 1. Then followed by the second term is n1 b to the power of 1. The third term is n2 b to the power of 2. Right, then plus n3 b to the power of 3. Then followed by the general term. And the last term is b to the power of n. Okay, so we're going to do a comparison. If you're going to compare what you're going to expand with the formula, right, you can clearly see that 1 is comparable with 1, right? Then your b is equals to negative 3y. Okay, your b is negative 3y. Okay, so we're going to substitute, and then your n is equals to 4. Right, so now we can substitute into the formula. Right, so we start off with 1, then plus 4, 1. So your b is negative 3y. Make sure you bracket it. Then followed by 4, 2, negative 3y, close bracket 2, followed by 4, 3, negative 3y to the power of 3. Then the last term will be negative 3y to the power of 4. So you should have 5 terms there. So let's check. 1, 2, 3, 4, 5. Yeah, so there are 5 terms. Alright. So we can't leave answer as in this form. We have to simplify it. So get ready your calculator. So to evaluate 4, 1, right, so you type in 4 on the calculator, followed by the shift key, followed by N0, followed by 1, you would get 4. Bracket negative 3y, 4, 2, 4, shift N0, 2, 6. Negative 3y times negative 3y. Okay, yeah, if you're not very confident, I would advise you to just write it up. No harm. So 4 shift N0, 3, you get 4. Okay, and then the last one is negative 3y. Okay, I think I'm not going to write that out. What I would advise you is just use the formula you have learned in the rules of indices. Right, in the rules of indices, you learn something like that, right? A, B, then to the power of n. Okay, we don't use n, then you can confuse with the use m. That will give you a to the power of m and b to the power of n, right? So that will give me, make sure you bracket it because you're dealing with a negative number. So bracket negative 3 to the power of 4, bracket y to the power of 4. Okay, so maybe we should use this ruler. It makes your working neater. Okay, so that will give you bracket negative 3. Make sure you bracket it. I keep emphasizing because it's a negative number. So bracket negative 3 to the power of 2, bracket y to the power of 2. 4 shift N0, 3, okay, it's 4. So that will be in bracket negative 3 to the power of 3, bracket y to the power of 3, followed by your last term. Okay, let's simplify further. So plus times negative will be negative, so that gives you negative 12y. Alright, this one here will gives you a positive 9. Okay, it's negative 3 times another negative 3 gives you a positive 9. Y squared here will gives you a negative 27. It's negative 3 times negative 3 times negative 3. So that gives you negative 27. If you want to use a calculator, you make sure you put a bracket there. It should be bracket negative 3 close bracket to the power of 3 when you use a calculator. This one will be a positive 81. Let's simplify further. So 9 times 6 will be 54. 4 times negative 27. That gives you negative 108. Okay, so that will be the expansion for bracket 1 minus 3y cross bracket to the power of 4. So what we have learned so far is a special form of the binomial theorem. So the actual binomial theorem looks like this. The general form looks this way. All right, so what we're going to do next is that we're going to use the general form that we learned earlier on, and then to come up with this, the special form we learned earlier on, to come up with this general form of the binomial theorem. Right. So let me write down the Okay, wait. What I'm going to do is, okay, let me write down the general, the special form. Special form is 1 plus b to the power n, right? This is a special form. Okay, right. Let's start off with this. Okay, I'm going to factorize a out. Okay, right. So if you can't really get what I mean, you just you just multiply back again. You see, a times 1 will give you your a, and a times b over a will give you b. So when you factorize your a out from a plus b, this is what you'll get. Huh? And I'm going to apply, remember this rule that you learned in the chapter on indices. We've been using a lot of these, right? So if you apply this rule, you will have a to the power n bracket 1 plus b over a to the power n. All right, so this part here, okay, is where I'm going to apply this guy. Okay, can you see? So what you'll be substituting in, okay, it's a bit confusing. So you may have to look at this slide a few times. What you're substituting in for b here, okay, what you'll be substituting for b here will be b over a. Will be b over a. Okay, so we're going to just do it carefully. Right, so the first term it's 1, then plus n1. Right, so I'm going to substitute b to be b over a. All right, so the next part is a bit tricky also. Okay, so we learned earlier on that n1 you should get n. Okay, and then I'm going to split b over a to the power 1. It's a bit tricky here. B over a to the power 1 is b over a. I'm going to split it into b times 1 over a. And then your 1 over a is a to the power negative 1. Okay, your 1 over a is a to the power of negative 1. So I'm going to write it as b. Okay, just write it as b times a to the power of negative 1. So this guy here will be n times b times a to the power of negative 1. Okay, n2, we can't do anything, just leave it as n2. Right, so that will give me b a to the power of negative 1 to the power of 2, right? nr, we can't do anything, leave it alone. So that will give me b a to the power of negative 1 to the power r, b a to the power of negative 1 to the power n. All right, so the next thing is I'm going to multiply a n into the brackets. So you have a to the power n times 1 gives you a to the power n. Then a to the power n times b times a to the power of negative 1. Okay, I know it's a bit confusing, but don't worry. We'll reach there. Alright, we continue at the next slide. Let's continue with what we have learned earlier. Let's continue to simplify it. Right, so if you were to look at this, this is a to the power of n times a to the power of negative 1. Right, so we need to apply this rule that you learned in your indices. Same base, you add the power. So that will give us a n minus 1. Then times n times b. So I'm going to rearrange it. Rearrange it, we are going to put n first. Then followed by a, n minus 1 followed by b. Okay, so let's continue. Right, so I'm going to expand this. Okay, using this rule. So that will give me b to the power of 2, then a to the power of negative 2. Likewise for the next term, b to the power r, a to the power of negative r, followed by the last term, b to the power n, a to the power of negative n. Alright, so let's simplify further. I would have a to the power of n. Now recall that n is just n1. n1 will give you n. Remember what we did for 6, 1, you get 6, 5, 1, you get 5. So n is n1. Alright, so we're going to combine this together to get a to the power of n minus 2, then b2. Right, I'm going to write this first. So that will be nr. This is the specific term in the binomial theorem. That will give me a, combine this and this. That will give me a to the power n minus r, br. Then my last term, can you see that a to the power n times a to the power negative n will give you a to the power of n minus n, which is 0. A to the power of 0 is 1. So you end up with b to the power n. Okay, so this, what we have here finally, is your general term for your binomial theorem. So let's write it down again. Okay, the good news is that this formula will be given in formula sheets in the exam. So you did not memorize it, but it will be good that if you can memorize it, it will be easier when you solve problems. If you can memorize the theorem rather than having to refer to it in the formula sheet. Alright, let's practice applying the binomial theorem. Alright, let's start with something that is simple. Let's say, for example, 2 plus 3 y to the power of 4. Okay, I'm going to expand that. Right, so let's do a comparison of what you have with the formula. Right, so you will see that we can substitute the values of a to be 2, the values of b to be 3y, and the values of n to be 4. Okay, I would really advise you, because you're dealing with two terms here, 3y, just put a bracket. Okay, just put the bracket there. So to remind you that later on when you substitute into the binomial theorem, you will have a lesser problem. You'll be able to get the correct answer. Okay, so let's continue. So we have 2 plus. Alright, so the first term is a to the power of n. So my a is 2. So it's 2 to the power of 4. Followed by 4, 1. Okay, 2 to the power of 4 minus 1 is 3. That's what I mean by you put a bracket there. So bracket 3y to the power of 1 plus 4, 2. 2 to the power of 4 minus 2 is 2. Then bracket 3y to the power of 2 plus 4, 3. 2 to the power of 1 bracket 3y cross bracket to the power of 3 plus the last term will be bracket 3y cross bracket to the power of 4. Okay, let's continue. 2 to the power of 4, if you use a calculator, that will give you 16. And 4, 1 is just using calculator 4 shift and 0, 1. That gives you 4. 2 to the power of 3 is 8. Bracket 3y to the power of 1 is just 3y. Okay, 4, 2 use a calculator again. 4 shift and 0, 2. That gives you 6. 2 to the power of 2 is 4. Right, this one you apply this guy here. So that gives you 3 to the power of 2, y to the power of 2. Alright, let's simplify further. So 4 times 8 times 3 gives you 96. 96y. 6 times 4 times bracket 3 cross bracket to the power of 2, that gives you 216 y squared. Then 4 times 2 times 3 to the power of 3, 216. And lastly, 3 to the power of 4, 81 y to the power of 4. Okay, that will be the expansion for bracket 2 plus 3y to the power of 4. Right, let's do another example. Supposing you asked to expand 3 minus x to the power of 4. Right, how are we going to do that? Right, we're going to do a comparison again and write down the values of a. So we can substitute the values of a to be 3. Now in this case here, you will have to substitute the values of b to be negative x. Okay, it's not x, it's negative x. Why is that so? Because the binomial theorem, the expansion is a plus b. Can you see it's a plus b? Right, so you have to substitute your b. If you have a negative x, then you have to substitute your b to be negative x. And make sure you bracket it. And then your n is equals to 4. Okay, let's do the expansion now. Right, so the first term will be a to the power n, which is 3 to the power of 4, followed by 4, 1. 3 to the power of 4 minus 1 is 3, bracket negative x to the power of 1, plus 4, 2. 3 to the power of 2, bracket negative x to the power of 2, plus 4, 3. 3 to the power of 1, bracket negative x to the power of 3. Your last term will be bracket negative x to the power of 4. So you should have 5 terms. So let's check. 1, 2, 3, 4, 5. Yes, correct. Okay, let's go on. 3 to the power of 4 is 81. 4, 1 is 4 times 27, negative x. 4, 2, use a calculator. 4 shift and 0, 2. Should get 6. 3 squared is 9. Negative x times negative x will give you x squared. negative n 3, that gives you 4. 3 to the power 1 is 3. Negative x times another negative x will give you negative x to the power 3. Finally, you will get positive x to the power 4. Let's continue. 81. 4 times 27 times negative x will give you negative 108x. 6 times 9 will be 54. And then 4 times 3 times negative 1 will be negative 12. And then the last term is x to the power 4. So it's now for your time to try to do the expansions on your own. Okay, the formula, the binomial theorem formula, I'm going to write it down for you. Okay, right, so if you look at part A, n is 3, so you expect to get 4 terms. Right, so 1, 2, 3, 4, yes. For part B, n is 5, so it's expected to get 6 terms. So we have 1, 2, 3, 4, 5, 6. So please try these 2 questions on your own and check to ensure that the answers are the same as what the answers I've shown on the screen.